Hello friends, welcome to Shiksharthi. In this video, we'll be talking about how to make a quadratic expression as a perfect square. So let's start. So I'm taking the same quadratic expression as ax square plus bx plus c. Now in which we need to understand that a, b, c are coefficients. We call a as the leading coefficient and c as the trailing coefficient. B is an interim coefficient. Interim means in between, right? So we are doing the same as we had done earlier. If you would see that we had talked till point 10 wherein we had talked about all the concepts and basics in the earlier videos. Taking it forward from there, the next thing is point 11 wherein we are talking about how to make a quadratic expression as a perfect square. So we do the same, we take a as common given the fact that x cannot be equal to a 0. Because if a becomes equal to a 0, then it no longer remains a quadratic expression and it becomes merely a linear expression. Okay, so we go ahead and then the best way to identify here is, the best way here to do is, if you just know the formula, for example, if I say how much is x plus y whole square. So we all know that x plus y whole square is x square followed by a 2xy, which is plus 2xy plus y square. So then from here you get a faint idea that if I'm able to write this thing as b by 2a, this cancels and gives me this only. So once I do this, I'm getting an extra term as, so I get what? I get x square plus what? Plus twice of x into b by 2a, which gives me this. So in any case, we have got these two terms. And the last term that you're getting from here is b square by 4a square, which is the extra term that you are getting. Now, since you are getting an extra term from here, you need to eliminate that term, which is why we are subtracting another b square by 4a square. Once we have done this, so this is nothing but this only. And then we need to add further this. This is what we had done. And then what we do further is, this is already a square, and then taking the LCM of the denominator and then rejigging it, we get this as x plus b by 2a whole square minus b square minus 4ac upon 4a square. Now there is a terminology which is introduced here itself, and the terminology that is introduced here is, we assume that we take this value as something. So we say that let delta is nothing but the discriminant. Certain people call it as delta. Certain people use a capital D for this, which is in any case is known as the discriminant. Now we'll talk about the role of discriminant in the subsequent videos, not in this video, because today's video we are focusing only on how to make a quadratic expression as a perfect square. So we assume that the value of delta here is b square minus 4ac, and thereafter we say that this is nothing but x plus b by 2a whole square root delta upon 2 whole square, and after this you can refer to the formula of a square minus b square. Now a square minus b square is nothing but a minus b into a plus b. So using this formula here itself, I can expand this, and once I expand this, I can finally write it like this. So you have to just work it out, and it is just a matter of seconds wherein you are able to work it out. And from here you get it as, so you should finally express it as what? You have already learned it earlier that if I say that alpha and beta, if I'm able to say that x minus alpha and x minus beta are the factors of a quadratic expression, so in that case I need to find out the value of alpha here. So can I say this is just like saying x minus alpha, so the value of alpha here comes out to be this, and the value of beta comes out to be this. Now what are alpha and beta here? If the moment I equate it to a 0, we know that a quadratic expression whenever equated to a 0 becomes a quadratic equation. So alpha and beta, they no longer remain as factors, they become the roots or the zeros of the quadratic expression, or quadratic equation to be precise. So the value of alpha is nothing but minus b plus root delta upon 2a, and beta is nothing but this. So what are we doing? We are just proving the certain formulas, and if you are proving something formula, if you're proving a formula, if you remember, we have always been at Shiksharthi, we've always been focusing on, we should try and prove the theorems. If I'm able to prove the formulas and the theorems, I come closer to the topic. This is what I'm doing exactly here. So once you have done this, then how have I made it a perfect square? This is just like saying the perfect square was already made here. This is just taking it forward and trying to find out what could be the value of alpha and beta when I'm finding out the roots. Right? Now once you have understood this, finally, if I am able to take an example, after which you'll be able to understand how to apply this. So all we have done here is, I have taken an example, I have taken a quadratic expression as 3x square plus 14x plus 6, and then we know that the value of the leading coefficient here is 3, the trailing coefficient here is 6, the value of b here, which is an interim coefficient, is 14, and if I were to make it a perfect square, I simply pick it up from here. Now even if I have forgotten this, but I know how to go ahead in steps, I need not memorize anything, because this I am talking about a generic way, and in all our videos we have been focusing only on the generic ways, because specific ways cater only to specific dishes on a plate, right? So even if I am unable to recall this formula, still you can convert this, and how you can do it is as we had started. So I have explained you the method also, and then thereafter we have taken an example wherein we have applied this. So part A, we were talking about how to make it a perfect square. Perfect square means in the format a square minus b square. A times of a square minus b square is the format in which we had left. Finally, if I were to talk about the factors of this, you can find out, you can identify the factors from here itself, because once you know, you have proven this, and you know that the value of alpha is this and the value of beta is this, you can do it that way also. Else you can work it out, and from here you could have said that one of the factor will be minus 7 by 3 plus root 31 by 3, which is this, and the other factor would be, other root or the factor here becomes x minus alpha. So and the other root, let's say beta, becomes what? It will be nothing but minus 7 minus root 31 divided by 3. Right? Once you are able to find out the value of the roots, then the factors would be x minus alpha into x minus beta. So thereafter you substitute the value and you get the answer. Finally, a learning from here you get something more to learn. So once you are able to get these values, you will say that these are irrational roots. Why are the roots irrational? Because you have a root here, under root. So the moment you have an under root, that means what? The roots are irrational. So maybe in our next video, we will be talking about the nature of the roots, the role of delta and ABC. Right? If you think that something knowledgeable has been discussed today, please do not forget to like, share and subscribe to our channel. If you have already done so, turn on the bell icon so that, and yes, don't forget to select all so that you start receiving updates from us. Thank you so much. Until next time we meet, goodbye.